We use whole numbers to count objects around us. 8 apples in a basket, 5 fingers on your hand, 24 crayons in a box. We use whole numbers to count whole objects. To measure the world around us, things like time, distance, weight, volume, we need to use a different kind of number. Numbers that lie in specific places on or in between the whole numbers. To express these numbers, we use decimals. So if I have my number line here, for example, and these are my whole numbers, the decimals indicate places that lie in between, like 1.5 between 1 and 2. 4.62 lies in between 4 and 5. With decimals, whole numbers are divided into tenths. So if I look specifically between the two whole numbers 2 and 3, for example, I can divide this evenly into 10 spaces, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And we can mark off this distance here by 10 evenly marked spaces, which is tenths. The number that is 3 spaces to the right of 2 is called 2 3/10. To write this number, we use a decimal, 2.3. The decimal point separates the whole number from the decimal parts. The number of tenths goes in the first place after the decimal point. So 2 3/10 looks like 2.3. To find the numbers in between the tenths, each tenth is divided into 10 evenly marked spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each of these parts is 1/100th of the whole number. 3/100ths to the right of 2 3/10 is 2 33/100ths. To write a decimal with hundredths, we use 2 spaces after the decimal point. So 2 33/100ths looks like 2.33. Hundredths can then be divided into thousandths, which can divide into 10,000ths, which can divide into 100,000ths, and so on forever. Each place to the right of the decimal point is 1/10 of the place before it. Each of these divisions gets its own decimal place. So if we're looking at a number that has a lot of digits after the decimal, each of them has a specific place. The first one here is our ones place. It's still the whole number. Then it's separated by the decimal, and the first space here is our 10th place. Then 100th place, 1,000th place, the next one, 10,000th place, next 100,000th place, then we go right into the millionth place. So if we have, for example, a number like 2.000003, the number that is 3 millionths to the right of 2 is written as 2.00003. Most decimals can be written as fractions. So if I have a decimal like 6 1/10, that is the same as 6 1/10. If I have a number, for example, 64.125, and I want to rewrite this one as a fraction, I look at the last place in my decimals, and that becomes my denominator. So I'm going to leave my 64 as a whole number, and then I want to rewrite the 0.125 as a fraction. I look at this at the 10th place, 100th place, 1,000th place, and I know then that my denominator becomes 1,000, and my numerator is the whole number of the decimal, 125. 64.125 can be read as 64 125,000th. Most fractions have decimal equivalents. 1/20th is equivalent to 5 hundredths, because 5 is 1/20th of 100. We can also find this using long division. So looking at 1/20th as 1 divided by 20, I can do the long division on this, put my decimal here, bring it up. 0 times 20, 0, 1 take away 0 is 1, put my 0 here, bring that down. 10, what times 20 is less than or equal to 10? I have to use another 0. 10 minus 0 is 10. I need to put another 100 here, another 0 there. Bring this down to make 100. What times 20 is less than or equal to 100? 5. And so I've got 100. And I'm finished with my long division, showing me that 1/20th, or 1 divided by 20, is the same as 0.05, or 5 hundredths. Some fractions have decimal equivalents that repeat themselves an infinite number of times. To truly express a fraction like 1/3, it would require an infinite number of decimal places, 0.333, and the 3's going on infinitely. For a number like this, we add a line above the repeating number to indicate that it goes on infinitely. So 1/3 can be written as 0.3 with a line on top of the 3. Irrational numbers, like square root of 2, have decimal equivalents with infinite decimal places, but without a repeating pattern. These numbers cannot truly be written as decimals or fractions. Decimals allow us to accurately measure the world around us. The distance to school, maybe 5.6 miles. The winner of a race may finish in 15.225 seconds, only 0.005 seconds ahead of the next runner. In the United States, a dollar can be divided into 100 pennies or cents. 1 cent could be thought of as 1/100th of a dollar. So $5.65 is the same as 5 65/100ths dollars, and can be written as 5.65. This topic will cover how to identify place values of decimals, add and subtract decimals, multiply and divide decimals, and convert and compare decimals and fractions.